So, hello and welcome to another episode of Flying High with Flutter. I'm your host, Alan Wyma. Today I'm with Hanan. I didn't even ask you how to even say the last name. Let me have a try. I want to say it in a Spanish way, but I'm sure that will probably be wrong. Am I guessing?
Okay. Yeah, we will be wrong because it's a Portuguese way, but anyhow.
Oh, wow. Of course, I want to say Arujo, but that's definitely wrong
Wrong.
because you said it's totally different.
Araújo.
Oh, my goodness. I don't think I could have gotten that the first time. I appreciate you stretching the imagination. Sometimes I think in English it's similar. Like you look at it and you're like, okay, I think I know how to say that, and it's like totally different. Like the word like colonel
Oh,
is spelled like colonial. These it's like totally different than the way you write it. That
absolutely.
drives me nuts. Usually those ones are like French, but sorry. Anyways, enough French bashing for once. Again, welcome to the show. We're here to talk about shaders, right? What I understand is that you're the guy who knows about shaders.
Okay, I am a guy that knows something about shaders. It's in the by saying shaders, I mean fragment shaders on Flutter. That's still an upcoming feature in the framework and the engine. So, for example, you have some people that's been working or experiment with fragment shaders for some time now. And what happened is in the last few months, the support for fragment shaders in Flutter in the master channel has went like into a revolution, and it's fantastic right now, but it's still under development. So you just have to keep watching on those and going using the imagination to see how what's the possibilities this new feature will unlock to the day-to-day app development.
I usually like to kind of go back in time and then kind of catch up to the topic that we're at today, right? So you're based out of Portugal, but you're working for Very Good Ventures, isn't that true?
Yes, it's a kind of a long story, but I'm Brazilian. And I moved to Portugal some years ago. I guess it's already 3.5 years. And I started working, messing with Flutter since I was back in Brazil, 2018. But I started working professionally with Flutter 2021, beginning of 2021.
Oh, that's very recent.
Yes, before that I just like did things in the sides, also some community work. Organized some events like the Hack 19, the hackathon in 2019 in the city of Campinas, Brazil. And I also started working immediately with open source stuff, packages, and libraries for Flutter since 2018. So the oldest one I have is PhotoView, which is a widget that you can display images in a fashion like image gallery, where you can zoom in, doing the pinch gesture, rotate, and stuff like that. And I also been involved since the very beginning with something that we call the Blue Fire, which is a collective of people that do some open source, maintain some open source projects, and also organize some events around some open source projects that we have. The most famous one is the Flame engine, the game engine for Flutter. And yeah, so this is like my nightlife in Flutter, where I do like between professional work. And professionally, I started working at this company called Rolls, which is a spreadsheet company, and we shipped one of the first desktop apps last year. I don't know if it can be used right now, but at that time, it was a huge case for Flutter. If you remember, the Flutter release on Windows featured our app. It was awesome. That moment was awesome to see our products being featured on official Flutter event. And after that, I joined VGV in this year, and I joined the team that maintains the open source projects for Very Good Ventures. So this team is me, Felix Angelov, and Wolfering. And we maintain projects like Very Good CLI, Flame Behaviors. We just released something that adds completion to command line applications, among others. For example, we help to maintain also things that are not from VGV, but are from us personally, like Block, Mason, and other small packages.
Okay, yeah, I didn't know you worked on Rose. I mean, Rose, yeah, I do remember that came out. It was huge, right? And it kind of came out, and then I never heard anything back from it again. And you're saying it may not even be out like publicly yet?
Yeah. As far as I know, they're not developing the desktop app is not under development anymore at this moment. So I don't know what's going on, but yeah, let's see what happens. At least the engine for the spreadsheet, the visual engine for the spreadsheet, and some other small packages are open source. There's this package called Sways that's actually the table engine that allows that huge thing to run, and it's 100% open source. There's some shards, some plugins. I guess we didn't lose a lot from that as a community speaking.
Yeah, I like I said, I do remember that. That was pretty huge. I remember, I think somebody came out on stage to talk about it, and
That was me.
yeah, was that you actually that came on stage?
Yes, I was in the video saying, "Yeah, we developed this."
I think you had less hair at the time. I'm trying to remember. I think it was a shorter hair guy. Was that? Didn't you have shorter hair? Or am I remember wrong?
Oh yeah, probably.
So you have the COVID hair right now, right?
Yes, if you can call it like that. Yes.
Okay. Yeah, I do remember somebody coming out and explaining about it. I thought that was really cool. No, I want to ask a question. How come you got chosen? Was it just is it your good looks? Is that what got you on stage, or what was it that got you up there?
Man, look at my face. Of course not. Of course, that's not what happened. Actually, what called the Flutter team attention was one GIF that I posted as a comment on a Twitter post. The Twitter post was from a fella here from the Flutter Portugal community, and he just asked what you were working on, and I answered with the GIF showing the table and the selection, and that called some attention. And the Flutter team contacted us, and then we started to do some monthly checkups on how was the project going. And at this moment, they said that we have this event going on. Do you want to be featured? We are going to release Flutter Windows. It's going to be published everywhere, yada, yada, yada. So we started to record a video immediately. And I wrote a small script. We went to some layers of approval. And after that, we just recorded the video. And also, after it was approved, we just waited. And was published. It was quite fun. A very fun experience.
Oh yeah, I'm actually looking at your video right now. I pulled it up. No, I was wrong. Your hair is not less. It's about the same as now. I just remember. Yeah. Okay. So did you get to keep the nice sweatshirt? Because that's a pretty cool sweatshirt.
Oh yeah, I have that. Just not wearing right now. I love sweatshirt from getting sweatshirt and swag from where I work. Because it's like free clouches, right?
Yeah, it's free advertising for them too, right? So
I have some VGVs too.
You got VGV stuff? How come they never sent me any VGV stuff? I'm sad now.
Oh, you can. Oh man, let's change that. Let's give you some swag.
Yeah, see if you hook me some swag. I can send some swag your way. I actually have some T-shirts. If anybody at home is listening to the podcast and you guys are interested in some swag, I've got stickers and T-shirts. And if there's anything else you guys are looking for, let me know. I got China right across the border. I can get made. Basically, everything's made in China, and that's right across the border from me. So it's easy for me to get stuff. But yeah, I do have some swag I want to give out if anybody's interested. But kind of back to the show. Yeah, so you're working at Rose. I mean, you work in this app. You got the exposure. You had your 15 minutes of fame, right? You were out there.
Yeah.
People didn't remember how tall your hair was, but at least they remember about Rose, and you worked on that. But what made you want to change, right? You went from Rose to VGV,
Yes.
or you did something in between?
No, I just went straight from Rose to Very Good Ventures, especially because the role I'm playing there, it's as an open source engineer. So as I was working not professionally with Flutter since 2018, maintaining packages and stuff, I already did lots of open source. This includes like the Flame engine, which is huge. Photo view is huge. So this kind of stuff I was already involved in, and I wanted to try something out, try something different, and this role happens to be like something unique. It's an open source team, so we will not work on we don't work on commercial products. We work only on uh, open source stuff. And also this involves also lots of community work too, and some kind of dev relations. We go to events like Flutter Vikings, for example, to talk about stuff. And it's really nice to have this ability to do this professionally, to receive money to work on something that previously I just used like my free time to work on. And that was the biggest factor that made me to try out Very Good Ventures.
Yeah. I'm always very curious about this kind of dev role, and kind of like, well, I guess the biggest question I have is, I mean, it's easy to figure out. Okay, if you're working on client projects, obviously that's how they can say, well, obviously you have really good value for us because you're helping to bring in revenue. Now, working on open source projects, that necessarily doesn't have direct revenue. I'm just kind of curious about how this kind of role has value to it. Is it just that you guys want to give something back to the community, or I'm it's not like I'm saying it's not that your role is not useful, right? I'm always kind of curious about what's the business justification, because a lot of old style thinking is always like, well, is this guy actually making me money? Well, you can't say that about your kind of role directly, right? So maybe you can explain more about that, because that's very interesting.
Well, that vision, it's the vision of having an open source team is kind of an interesting vision, because you have to look into all the indirect influence that these projects have in the ways that we can bring revenue to Very Good Ventures. So the biggest way of bringing revenue to companies like Very Good Ventures that have software services is, I guess, the one we can see like almost time to time is when you build in the open, you have your code is visible. So this intrinsically drives some kind of a pressure on having a good code quality. In this case, very good code quality. And this affects all the projects, even if it will not be open source. If you have standards, like that's one thing that's very interesting on VGV. They are very strong on it. It's standards. And we have lots of projects, lots of clients, and now have a standard. So if someone have to change between projects, for example, will not face a code base totally different. And we always can rely on code quality, on tests and good practices. And this all comes from this kind of projects. So we have this direct impact on internal projects. And even though we have the open source team, the entire company has this kind of open source culture. Even like engineers working on the commercial projects, they may have ideas for open source projects, and they may work on it. So this is what happened with R13N. It's a package we launched some months ago that's just for regionalization of rules. And this came from a project in the commercial side. So it's like a two-way street where we collaborate with the commercial projects, and also the commercial projects collaborate on open source too. And there's also all the obvious indirect gains that Very Good Ventures can have from having some kind of having the standards applied internally visible and being adopted externally. So, for example, we use Very Good Analysis, or Very Good Workflows is being used in several other projects around the community, and I guess it's very, very positive for everybody. And even though we have like this commercial side of Very Good Ventures and the open source side of Very Good Ventures, the open source projects are not does not tie anyone using it to Very Good Ventures. Like you are not owing us anything if you're using Very Good CLI, for example. And I guess that's a big win for the community too. So having a big impact in the community, there's also that big impact on the view that people have on the company. So I guess I heard this a lot on events, for example, on Vikings. The Very Good Ventures it's well seen among the community, and I'm really glad to work there because of that. And this helps a lot on people when we want, for example, to hire the best people. These people will know Very Good Ventures. So this kind of stuff, you know.
So then now we can say that you're the best, one of the best people now.
I guess I fooled them on the interview quite well.
Yeah. Oh, that speaks for your talent. I think working at Very Good Ventures is something a lot of people kind of aspire to, which is good. So it's interesting to hear that somebody who just started off in 2021, if I remember correctly, is already at VGV.
Commercial, yeah.
Yeah. So that must speak to your dedication and passion within Flutter, right? Now, what were you actually doing before you got into Flutter? Because we didn't actually really talk too much about that.
Oof. Yeah, dark ages. I was doing JavaScript, man. I worked on. I started as a front-end developer, so I just love, and to this day, I just love CSS more than almost anything. Not including people. I love people more. Some people. Anyhow, I just love CSS until this day. So I started like back in 2015. Yeah, just working mainly with HTML and CSS because it just this one thing you'll see from my projects. I love design stuff and I love visual stuff. I love user interfaces. After that, I got into the world of JavaScript, React. I worked with React in lots of projects back in Brazil in a company called Dextra. And there was this project that was a mobile app that needed modulus. And then I joined the world of mobile with React Native back in 2017 to 2018. And in 2018, I discovered Flutter. So it was until 2018 and 2019, I was just working with on my day job, work with React Native, and at night I tuned into Flutter and started playing out and learning and creating open source stuff. And then I moved to Portugal to work at Rose, starting with React, and there was this moment that they needed a desktop app. So there was this option between creating one with Electron or creating one with Flutter. We went with Flutter, and the rest is history.
So what was your first kind of experience when you started working with Flutter? I mean, because you came from JavaScript, right? JavaScript, you can do a lot of stuff. And have you ever seen the Wat Man before?
No, the what?
I have to share it with you after this call.
Okay.
So there's this guy named Gary Bernhardt who does this video called Wat Man. So did you ever hear the term Wat? W-A-T? It's basically like saying what, but it's like Wat. What is that?
Oh, all right. Yes.
Have you seen this Wat Man thing or no?
No, the Wat Man thing, no.
Okay. Well, when you watch the video, you understand why it's called Wat Man. But he basically is saying, okay, let me show you something about JavaScript, and you start doing weird things like saying like array plus object, what does that equal? And you get weird stuff. And but like coming from JavaScript interestingness to kind of more standard Dart, like do you feel like what do you feel when you go from like that kind of style?
Yeah, I was in the reality of working with TypeScript. I was barely touching pure JavaScript at that moment. So some stuff from TypeScript to Dart it's a quite straightforward way. There's some punctual differences, but it's mostly always improvement. Everything you learn from TypeScript to Dart, and it was okay. When I started, we were on the Dart 1 yet, so typing was not that strict. So some stuff I just fell home instantly. But when came Dart 2, now things got interesting. And the strong typing that came with that was just awesome. So my experience was mostly positive. like mostly 9% positive. And also that helped. A fact that helped that was I was working with React, and React, the way React works using components, you can translate that to widgets. So there's some stuff you can translate from a React developer to Flutter. That's very straightforward. And if you go learn Compose and SwiftUI, there's some stuff that quite some concepts are quite transferable between those platforms.
Yeah, definitely, right. Like especially the ideas of composition. I think compositions is something that's
Yes,
quite new. Otherwise, I think most things were like class based, right? Even now, if you work around with React, like they stop basically most class based components, if I remember correctly. Like everybody's using functional based, which I thought was very interesting.
I mean we don't use inheritance a lot on widgets, right?
Yes, I do find that strange, but it does work. But
this is the thing about declarative UIs. You can declarative UI is just a way of it's just a description, a prescription to the framework, whatever it is, to build a screen. You're not actually building the screen. You're not actually dealing with the objects that will be alive during the interaction of the user. We are just writing a description of it. So widgets are just a recipe. So how can you declare UIs given that condition that we are not actually dealing with the things that will go live, that will be alive during update cycles? Composition. So you just need a method or somewhere that describe that composition. So since we're not messing with things like all the time, we're not messing with things like render objects, for example, or more advanced concepts, it's quite straightforward. Just compose.
Now, I think we've gotten quite a bit of your background, and
yeah,
we know that you're a superstar being on the Rose team. Let's talk about shaders a little bit, right? So why don't we kind of go into a little bit about why you dug into shaders, right? Because people don't usually dig so much into certain topics, but what got you into getting more into shaders?
If you see like how things are connected to each other. So I was working at Rose, and while doing that project with tables, I learned a lot about scrollable stuff. Like a lot. Like everything scrollable is levers and everything. It just was there in my mind. And I submitted for a talk on Flutter Vikings about scroll. And scrollable APIs, kind of an unknown scrollable APIs that people can take advantage of. And while I was doing the slides and working on all the subjects I was going to talk, said, okay, we know that the APIs we have right now are awesome, and we have all these values we can access, but how can we make this even more epic? So in the end, I started to experiment with Umbra, which is this package that my coworker, Wolfgang, created around shaders at that time that simplifies the creation of fragment shaders on Flutter. And at that time, using shaders on Flutter was really, really difficult. There was lots of limitations, some stuff that I didn't want to put the hands on. I just wanted to demonstrate, scroll. So my idea for a shader was a motion blur as you scroll. So if you scroll fast, you have a motion blur. The best way of doing that is having a fragment shader. Since the fragment shader support was experimental, it's still experimental, but was even more experimental at that time, I just wanted to do some kind of a gimmick in the end of the presentation. So I just wrote a fast shader there, used Umbra, and then demonstrated, and it was quite fun. Everybody loved the demonstration. And I was like, okay, shaders are quite powerful and quite fast. And we have lots of runtime values that we can use as parameters for shaders, especially on Flutter. So let's allow the imagination go ad infinitum. So last week-ish, 2 weeks ago, I don't know, I went back and checked what was going on with shaders, and the support was just something else. It was quite easy and way more powerful. Some shaders we some features we wanted to use back in September was not possible. It was possible now. So we just, okay, let's go for trying out the stuff. And then I came up with this idea of having this shining shader, and then I shared on Twitter, and it blew up. It was quite awesome to see. And it was also quite awesome to see how fast you can post-process a Flutter UI with shaders. But I guess I'm getting ahead of myself here, because if someone that's listening and doesn't know what a shader is, basically, in this case, I'm talking a specific type of shader that's a fragment shader, and that's a kind of a function that runs for every pixel of the screen or of the canvas we're putting the shader on. And we run this for every pixel, and the shader doesn't know the results of the other pixels. And also, it runs on every frame you repaint. So it's quite powerful. But the most important thing is it runs on the graphics process unit, not on the CPU. So it's quite fast for graphical processing. And you can pass several parameters, several different types of parameters to shaders. For example, any double value you have on runtime. For example, how much you scroll the page, or the result of a drag gesture. I don't know. All of this kind of stuff. Even a color, for example. And you can also pass, we called textures. It's basically an image. An image, a Dart UI image that can be the result of the processing of a region of a widget tree. So, for example, you can post-process the image of an entire app with one shader and apply some kind of a sepia or contrast, or make everything black and white if you want to. And so this is basically a summary of what's a shader. And the support on the master channel is quite fun. Can do lots of cool stuff here.
Now, so you're saying that on master channel you can do some stuff that you cannot do obviously on stable, right?
Yeah, I mean, I don't know if you can use fragment shaders at all.
Why is that exactly?
They have been working a lot on this support, and there's this new graphics backend. I don't know if that's the correct term, called Impaler, that is being developed under development for some time now, and it's basically an alternative to Skia. And since it's maintained by the Flutter team, I guess it's more tied to the needs of Flutter. And Impellers, I guess you run by default. It's a default graphics backend on macOS, on iOS in the master channel. And I'm not sure. I may be talking bonkers here, but I'm not sure if it's usable on the stable channel or beta. I have to test it out. Didn't test that. And I'm gonna drop here in the chat the link for Impeller. And the support of fragment shaders is a little bit better now because of all the development in the engine around this kind of support,
So what is better in the master channel when it comes to shaders that you don't get in stable or maybe the beta channels?
Okay. Can I share my screen? I'm really into share my screen.
Yeah, please go ahead.
This window here and share. So this is the documentation that just got added to the website. So it's writing using fragment shaders. So this is the title in the docs site of Flutter. So but basically we have on master, you can write the shader file somewhere. In this case, the person puts under shaders and the name of the file and loads as an asset. So since you have the what we call the fragment program, which is basically your shader compiled. You can create the actual shader from that and use on a canvas. This is the basic usage that we have on master. And there's this package. Let me see if I can find it. It's called Flutter Shaders from Jonah Williams that provides some APIs that makes even easier to use shaders. So for example, here, if you go to the example app, it's just a Flutter app, and we have a shader file. So for example, we have this shader. Nice. This is not Dart. I'm going to explain a bit. We have the shader file, and we just load in a similar fashion as we load assets. In this case, we have the special key in the PubSpec YML that's for shaders. And then we have some APIs to use them dynamically and try apply them on Flutter apps, on the actual user interface of the app you're building. So I got some examples here. I guess I can go for this one. It's the same from the tweet. This is a Flutter app running on macOS, and it's shiny. So as I move my mouse, there is some kind of a light effect on the letters that's applied to the canvas of the image. So what's happening here is, let me go for app. So this is just a normal Flutter app. I have a page that contains just widgets, everything we know about. There's some examples. So every part of the screen here is some kind of example. There's a text editable. There is a long test, which in this case is this example here, and also the image, and also a Rive animation, just like this one. Okay, so what's the intention with this is to show how all the values that we have on a Flutter runtime can affect a shader, can affect a way you can customize a shader. So for example, here, the shader has a light source parameter. Because there's source X and screw fraction. So this is kind of the coordinates of where in the screen the light source is, and that is customized by different parameters I have in my app. And it's all just a Flutter. So I can edge this test. It's just a Flutter UI as like any other, but I'm post-processing it with the shader. How that's done? That's done by some helpful widgets that we have on the Flutter Shaders package. There's the animated sampler, which is, it receives a child, receives a widget, and runs this function with the image that's resulting of this widget. It renders a widget, takes the image of that, and then you can process it using the shader. And that's it. And you can pass the image as a parameter to the shader, and then the shader will do the actual job of painting every pixel of this part. And yeah, as long as it's not a platform view, it will work with any widget in below. So this is basically a photo view with an image, and I'm just applying this as I move my cursor. This is one parameter I pass to the shader, and the other is how much I'm scrolling, and it's another parameter that I pass to the shader. So this is quite a rather complex example, but shows how fast it is right now. I'm not sure about like memory footprint or impact on battery, but it's quite fast to apply these changes. And with all the flexibility we have on Flutter, the sky's the limit. So I even have, for example, this was the demonstration I added on the Flutter Vikings example. So it's updated to use the new stuff. It applies a motion blur as the velocity of my scroll changes. So if I'm scrolling fast, it will apply. I guess my screen share is probably not the best if I'm looking here, but once you have like 100 frames per second, 60 frames per second, as we can see here, even on the bug, you can see that this is quite cool. So this is just another example, and there are some other small stuff we can do with images, and this is my playground where I just pass out some shaders. So I have some photos I took during Flutter Vikings here, like this one, this one, and this one, and I just apply shaders on them. So you can apply shaders on images or even on user interfaces. In this case, I'm applying a brightness shader to this image. So how this is happening? I have I load this image from the assets, pass it to this widget here that applies the shader to a custom painter, passing the image as sample and also its size to the shader. And there's the slider value, that's the value from this little material slider here in the bottom. I pass also to the shader. And then the shader file, which is, in something, it's not Dart, it's a language that we call GLSL, which is a specification of a language for shading. So it's like OpenGL shading language. And that's quite familiar to C, and it's a C-like language. And what it is, it's just a function that runs, as I said, to every pixel, and we have some parameters. The only parameter that we have on this case for Flutter, for shaders supported by Flutter, is the coordinates of the pixel that we are painting, and everything else we can pass as we call uniforms. Uniforms are parameters that we pass to the shader. In this case, we are passing here. And on Flutter, they can be two types. Images, in this case, an image sampler, and floats, float values, basically translate to double in Dart. In this case here, there's the first uniform we're passing. So the order of the uniforms are quite important. In this case, it's a vector 2. So it's basically a vector of 2 dimensions. So it receives 2 values. We just pass in sequence the x and the y of the vector. And after that, we have just a float. So it's just one value here that we pass here. And after that, you have to pass the image. That's basically the texture that in this case will be of type sampler 2D. And you can have other types here. For example, if I pass here a vector 4, for example, I have to pass this, and this for the shader. And also I have to maintain these numbers in order. The order of the uniforms are very important. So yeah, you can pass basically anything. So here we are passing this parameter here and the size. The size is basically the size of the canvas or the image, sorry, which is, I guess, the same. And the actual value of the slider that here is called udelt. I'm starting with U. This is something I'd like to do, to name uniforms starting with U. Is to name uniforms that are textured with T. And the output of this shader is the color of the pixel. Color is a vector 4, so it's just 4 numbers, R, G, B, and A, so the channels of the color. And it's called frag color here. It's indicated by out because this will go out of the shader. And we just specify this in our main function. What we're doing here, we get the coordinate, the raw coordinate, the number coordinate of the pixel we're painting, and we get that in a relative number of the actual size of the canvas. So if you have a canvas of 100 by 100, and I am the pixel 50/50, this will be in the middle of the screen. So the value of this that we call the UV is 0.5, 0.5. So vector 2 in the middle of the screen. This is like a relative number of the coordinate that we are painting on. And from that, we can call this a special function here that exists on GLSL. That the first parameter is the image that we're passing down from Flutter, and the other is the UV that we just created here. And from that, I can grab the color of this specific pixel in the image. And with the color, we can do anything and then set that as the output. So this is a very basic shader that we're just adding some brightness. So this brightness function is very simple. Just get a number between 0 and 1. I am adding 1 here for to make the values a little bit more visually appealing. And I multiply RGB with that value. So I get the amount of R that we have, and we multiply by the amount of brightness we have. And this makes the color more bright or not. Or I can just, let's just kid around. So I'm going to make RGB here be like vector 3, 1.0. I don't know, just 1.0. GitHub Copilot, give me a break. Thanks. It's just making it completely white because it's painting every pixel as white. Or can toy around and make the red channel always 0. So we're just removing red from the color at all. So we can toy around with the colors a lot, and it's quite fast. Yeah, that's like a summary of how what's a fragment shader is. And my intention now is to show like how the daily basis, how the daily work with Flutter can be impacted by this kind of technique. We have one thing in the framework that I don't know if I have here is the overscroll behavior. Do you know the overscroll behavior on Flutter 12? What it is?
Wow, I think I had somebody on an episode talk about this one recently. It's changed with Android 12. Yeah. There's used to be an inkwell, but now it's something else. I think. Oh, sorry. There's a stretch, right?
It's a stretch. Yeah. It's a stretch. So let me just Google here because I don't have the tab open. Material 12 stretch. I guess Material 12 Overscroll. Oof, this first link here, it's Flutter, but I guess I have an animation over here. If you can see, as the user overscroll, it stretches, but it's very important to notice that the edge of the screen, it doesn't stretch much, but gradually, as you're approaching the other edge of the screen, the stretch is more visible. So if you use something like a scale, transform and a scale on Flutter, you will stretch the entire UI. That's what I guess it's implemented on the stable channel for Overscroll Material 12. Yes, it's somewhere over here. And this is a feature tracked to be solved with fragment shaders in this case. So I hope I thought like some minutes before this talk, I thought, wow, what we can write live as a shader. I guess this could be like a very simple type of shader that we can make. What do you think?
Yeah, I think you should be able to. I would like to see how you do this.
All right.
I'm guessing you already did the work.
Okay, so
right? Or you just got live code everything from the beginning.
I did. No, not everything from the beginning. I cheated a little bit. So I have this playground that's just editing an image. I have another playground that's just scrollable. So it's just this scroll view. Okay, but this, it's not a very simple scroll view. It's a scroll view that I have my own overscroll behavior. So in this case, let me just show the source code here. We have this list view builder that shows an Oslo photo and this title in the beginning. And I have 10,000 items. I don't know, I can change that. I have a huge cache extent because I don't want to scroll and load the images dynamically. It's not visually appealing for this demonstration. And I have wrapping this scroll view, this list scroll view. First, a scroll configuration, which is from Flutter, something that we can customize the working of a scroll view. So in this case, I'm forcing that touch will drag the scroll, so I can, like with my mouse, I can scroll like by dragging, so I can emulate some mobile behavior. And then you can drag with the touch screen. Also touch, mouse, and trackpad. So trackpad too. And I guess that's it. I'm gonna just remove the default overscroll behavior on this. And I'm wrapping with this special widget here. This is the secret sauce. This is special widget, which is the apply shader thing. It wraps the children with the two things that I just showed. One, the thing I just showed is which is the shader builder, and also this special other widget from Flutter Shaders, that is an animated sampler that creates the image of the child. And here I'm just disabling this whole shader behavior if I don't have overscroll. And yeah, just passing the image to the shader, also the size of it, and also the overscroll amount. And the overscroll amount is calculated by this special widget from the framework that's called notification listener, that will listen to notification that is emitted from the list view. In this case, scroll notification. If it is an overscroll notification, it just calculates the delta that I'm overscrolling. If it's a scroll end notification, so I just stop it, the overscroll, it will make the delta go back to 0. All right. So in this case, I'm using the brightness shader here, and I'm passing the overscroll amount, which is the delta based in the whole dimension of the screen. So this is equal to the height of this list view. And the overscroll amount is just this ratio, and then I'll pass to the shader. So I'm just gonna go a little bit of an overscroll. You see, as I overscroll, it goes brighter. I'm gonna make this a little bit more dramatic. Thanks, GitHub Copilot. See, I'm overscrolling now. It's making it bright. I stop overscrolling. It doesn't go bright. All right. So we have a shader working here, but I want to stretch and I want to make it bright. All right. I'm going to go back to that playground. Let's write a new shader here. So I just have this thing that I keep here. It's just the boilerplate of all shaders are right. What's the details here? This specifies which version of GLSL I'm working. 460 is the latest one, so I make sure the latest resources are available here. I can use the old things, for example, the 100, but lots of data types are not available in this version. So just making sure we are using the last one. This I'm making specifying the precision of floats. So I don't want like a huge precision here. I don't need a huge precision here. Make it a little bit faster, just setting as medium. This is the only thing we can import right now on shaders. So this gives us this function that gives us the coordinate that we are shading right now, independently if you're using Skia or Impala. and just calculating UV, running the fragment function that will return the color, and that's it. So we have a basic texture as uniform, and the other uniform is the size that we're passing here. So I'm just gonna change our playground here to boilerplate. I'm not gonna create another one. I'm just gonna check out whatever we do now. Okay, just passing boilerplate. Boom, there's a problem because we are passing one too many uniforms. So yeah, this boilerplate shader is doing exactly nothing, which is whatever we need right now. All right, let's stretch. How do we stretch? It's basically comes down to getting a different coordinate that we are shading right now in the image. So if I'm the middle, I wanna get not the middle coordinate of the image. I want the coordinate of the part I want to display. So if I'm stretching and I'm painting, for example, this widget in the middle, I'll be actually painting this part of the image. I don't know. So this comes down to change UV. So let's go for a vector 2, UV2. Oh, nice, but not this. Let's go for 0.5, for example. So this gets like the half of the coordinates. So for example, if I'm the end, I'll get the middle. If I'm the 10% of the height of the image, I will get equivalent of 1%. So it's going to stretch a little bit. Go for this. Oh, it's not working. Oh yeah, I'm not texturing the UV2. Whoa, I guess it's too much. Let's go for 9. 9 is imperceptible. Okay. As I can vary, this will be stretching a little bit more. I don't want to stretch both coordinates, just the vertical one. So let's go for a vector 2. Oh, thanks, Copilot. UVY. So I'm just going to stretch vertically. Nice. This is it's a value that's like hard coded here. How about we get the value from the slider? So we can have another uniform, float of U amount. It's a very common name that I use like most all shaders. And we have it. Oops. Oh yeah, we are not passing this. Let's uncomment this. Boom. I guess it's working now. As I slide this, we are stretching the image. So changing that value, we're multiplying. But this is stretching like the whole thing. As I go in the top, I don't stretch much. In the bottom, I stretch a lot. This is the effect we are going for. So I guess this value that we multiply UI varies as UVY increases. And also it's like the inverted effect. Like 0 is applying a lot and 1 is applying like nothing. So we can just invert this by going for a float, real amount, I don't know, or inverted amount. Inverted amount would be better, but it's too late now. It's like 1.0 minus this. Let's just go back. Oh yeah, not using real amounts. Come on, man. Good. Now we are applying this to the value of the slider. Okay. And okay, let's vary this value with UVY. So we can go for using PAL. Okay, this is a quadratic function, so it's like we'll increase in the different manner, but I don't want a quadratic, I want to vary based on UVY, I guess. I guess we are a little bit better, right? We are not stretching a lot to the top of the image, And we're applying the value, the effects more dramatic in the bottom of the image. We can go for UVY times UVY. I don't know. I'm just guessing right now. Oh, 2.0. Yeah, thanks, Copilot. Make it a little bit more dramatic. Boom. Or 0.5. So we just toy with math and stuff like that to apply the value. And the difference right now between the top of the image and the image itself, it's way bigger. Let's go for like, this is like more subtle, but as we reach 1.0, boom. So we are just toying with the function, the mathematical function here. And I guess that's a good shader we have here. I'm gonna just change let's apply to the scrollable thing now. Breakdown scrollable. Let's change the main for the shader playground scrollable. Let's change to our shader, which I'm just using the boilerplate one. Just gonna duplicate afterwards. Let's go. We are applying the overscroll, the material 12-ish overscroll. But as I stop overscrolling, it suddenly goes back. So we can use the magic of Flutter to adjust that. I'm overscrolling, I stop, boom, it goes back because I suddenly set it to 0.0. We can use a twin animation builder here, perhaps. Twin animation builder. This receives, it's a value widget builder that goes for context. I'm gonna call this delta again. And then this is just a child, I'm not passing. And then here a twin. Let's go, Copilot. Thank you, Copilot. Oh yeah, I have to pass a duration too. Milliseconds, I guess it's good. Oh, I don't wanna twin this while it is overstretching. So if delta is bigger than 0.0, okay, thanks, Copilot. So this is basically what I created, the duration that varies. If I'm going back, if I'm setting to 0, suddenly it animates during 100 seconds back to zero. And if I'm just in this situation where I'm overscrolling, this doesn't have an effect. So I'm just passing delta here. That will be used to calculate the overscroll amount. That will be passed to the shader. Let me just remove this right now. Let's see. Ooh, it's quite fast, I guess. Oops. Guess the logic is inverted here. Let's go for 300 milliseconds. And then we have the animation when going back. So we have all the flexibility of Flutter with all the flexibility of shaders to create amazing stuff. So the sky's the limit now, and people can use all the values that we already have on Flutter as parameters to shaders to just go wild. So I guess this is for demonstration that I wanted for today.
Yeah, that's pretty cool. Yeah. I think your examples of what's on your Twitter are really cool. Like I remember like seeing was it like a sun or something? I thought that was really cool. Is it just me or am I remembering like when you have like the
is
Chrome?
It this?
Well, I don't know what is this right now. Let's see. It wasn't this.
This is the Twitter one.
No, I don't think this is the 21. I for sure something like this was there, but it was like somebody running. right? It looked like a video game the way the shader was.
Oh, the Trex.
Yeah,
It's
the
on Flame.
T-Rex. That was on
Oh,
Flame.
I
Okay.
don't have this example running here.
Yeah, but that was
Yeah.
super attractive.
So yeah, we have the Flame engine.
Yeah.
Yeah. What happened there? Let me see if I can find the tweet, because in the thread of the tweet I kind of explain how this is applied.
Mhm.
So what happens is Flame is just a widget, just a game that runs on a widget, and everything is canvas based. So what happens is I duplicate this widget, and in one widget I run what will be used as parameter to the shader. In the other widget I just run the whole game, and then I use a stack to put everything on top of each other, and that gives that effect. So let me just find where's the. Oh yeah, here, found it. Let me just put on the screen. So this is the Trex. The Trex is like an example on the Flame Engine repository. So it's already implemented. I just added this visual effect. So what happens is we have the moon. It's kind of a moon, and we have some elements that causes the shadow when they pass on top of that moon. So it basically uses the very same widget that we use here. It's the very same thing, the very same shader. I'm sorry. But with some Flutter techniques. The difference is on the Flutter side. It's not even GLSL anymore. So this is the two versions of the game that we're running. On the top is where I don't apply shader, and on the bottom is where I do apply. The blue part doesn't go to the shader. It just I added here to illustrate that this is transparent, so it's just empty pixels. The blue parts, and the dark parts and white parts go to the shader. And this shader uses luminance to apply the light, so only the white part will have the luminance, and everything else is just the silhouette of everything else is just to cause the shadow. And when I apply the shader, and instead of running this version of the game, I run the shader, so we have this kind of effect, just the moon and the shadows on top of it. And then after this, I just use a stack. I put the version with shader on the top and the version without the shader on the bottom, and we just compose this visual beauty that is this part. And if you look closely, this part where the cactus is on the front of the moon, it appears like darker, but it's just like visual illusion, optical illusion, because it has the same color, but when you have a darker background, it looks brighter. So yeah,
this is super attractive.
This is the technique. So this is the kind of stuff that I want to people know, that shaders is not just a gimmick. You cannot just go and do this kind of stuff. You can use in the real Flutter development every day. Just the thing that made me fall in love with Flutter, I don't know if that's your case, is that you control every pixel of the screen. Mm-hmm. And this factor now, it's even more impactful with fragment shaders.
Yeah, I think this is pretty cool. But yeah, I think the difficulty of the shaders is that you have to really get into, it's a totally different syntax, right? It's similar to C style. I think it's called GLSL. I think is the name of the language.
GLSL.
Yeah, so that's basically the open
GLSL. It's OpenGL shading language. But it's once you get a grasp on what's a shader, this concept of what happens there, what a shader knows and what doesn't know, with the answer is it knows only the parameters. It doesn't know the results of other parts of the screen in that shader. So you can't combine the results of two pixels in one, for example, unless you do multi-part shader, which I can explain later. And the thing I use it to learn shaders is this online website, and it's like the reference for everything. It's even on the documentation here on Flutter. is this online book that's called the Book of Shaders. It's just in 10 to 12 minutes you'll get the basic understanding of what's a shader, and even has this editor where we can just play around. Just like the Dart pad of shaders, so you just can play around with a shader here to create visual stuff. I don't know, without having to go all of this hassle of compiling and everything. And also examples. There's lots of examples there, so you can just Google stuff, GLSL, and see if Gaussian blur GLSL. There is blur. There are some people asking. It's a very very widespread technique, and most people will probably not need to write GLSL like every day of their lives, but it's a fun technique to know. And if you like to just to play around, I can spend a whole day just customizing parameters and stuff like that to see the output,
Yes.
So if you want to learn shaders, the Book of Shaders, and also this documentation, writing and using fragment shaders, this is on the Flutter Docs. That's it.
Great. Yeah, this is all really cool stuff. I kind of want to play with shaders when I have some time. It's too busy these days, but yeah, you can do some really cool stuff. And I always hear people talking about shaders and they're useful, and people complaining that they want more access to shaders within Flutter. And I'm like, I don't know. Most of the apps I make, we don't really need to do this kind of stuff. At least for the apps that I need to make.
Yeah.
But I mean, there probably is a couple of times where I did want to do something and I couldn't quite figure it out, and maybe shaders could have solved the problem. I think it'd be worth it to kind of just to
Yeah.
go through this website like you have over here, get an idea about what a shader is and what you can do with it.
Yes. There's some ideas that I have that can be like useful with shaders. There was this one that's I saw on Twitter some days ago. It is kind of a progressive blur that you can apply to images. I guess this is it. Oops. It's a kind of progressive blur that you can add, so you can animate this kind of stuff,
Oh, that's nice.
and apply to any image. You don't need to tell your designer to process image in Photoshop, then ship to you. Then you can put on your app. You can like download an image from the internet and just display it and apply the effect on top of it. So give this kind of flexibility. And the support that we have of shaders on Flutter, particularly speaking, this capacity of sampling the actual UI of the screen, shaders, it's like a very very powerful. Not even no web technology have that flexibility. For example, unless you're using 3JS, but if you want to sample the DOM, then pass to 3JS, it's not a fast nor cheap, computationally speaking, cheap operation. And if you compare that with Flutter, boom, it's just its own thing. So the possibilities now that we have with Flutter, it's like we see a lot of people publishing demos of Swift UI or Compose or anything like that on Twitter, and then someone from the Flutter community goes and replicates that with Flutter. I guess the possibility now is for we create demonstrations and people of other technologies try to replicate it, because we can have Flutter now on the vanguard of some types of user interfaces.
Yeah. Okay. Yeah, I think I just need to go through this some more to really wrap my mind around it. But I can imagine some things. Like what's already coming to mind is like I think it's like Arrow or whatever, like the Windows Vista kind of style, where it's like you have like this kind of iced, you can see it, but it's a little bit blurry kind of thickness. I don't know if you remember what I'm talking about with like the Vista Arrow. Like that thing I think could be done with a shader.
Yes. All the types of blurs, motion blur, zoom blur, Gaussian blur.
Yeah, I didn't think there's so many different types of blurs in this world, but I guess there's a whole book of blurs we should probably make.
There's this one. I guess I just copied this from somewhere on the web. It's called the barrel blur. Let me try. Let me see if I can apply this to barrel blur to our caps lock was on barrel blur. And let me see if I can apply this. Ooh, we have it. Oh, it's not dependent on.
It's still
the
pretty
amount.
cool. Yeah, this is
So
cool.
yeah,
yeah. It's almost like an ND filter or something on in the image. It's really nice.
Yeah. And this is a possibility to the thing that I used to learn Flutter was an app that I wanted to create that's it's just an image editing app. It's called Let's Picture. It's published on the Play Store, I guess. And it uses the CPU to apply contrast, brightness, saturation to images because I didn't want to pay for something like Lightroom to treat images that I take. But the limitation is that I use even using the FFI, which made it a little bit faster. I was using the CPU to edit the images. Now, if shaders using the GPU, the possibilities are just immense.
Okay, yeah, this is pretty cool. Yeah, I really enjoyed you kind of walking through shaders some more with me, and now I understand a little bit more about what they are and what you can do with them. And it seems pretty. I mean, other than obviously learning the language and learning all the math and stuff behind it, I think adding shaders to your program seems to be really straightforward. Like you just have to create the fragment and stuff. I feel less scared of it, but still, I don't really know too much about the shading language, the GLSL. That's something they have to pick up. But otherwise, once you learn that, I think
the languages are easy. Always. Yes, I mean, I had a great experience. Just for a context, before 15 days before Flutter Vikings, I didn't even had an idea what GLSL was. And during Flutter Vikings, I just did a demonstration of it. So it's quite easy. It's quite straightforward to learn this language. You just need to understand some principles, like the types and where it runs, and take care of some examples because some examples may be from an older version of it. So they may, if you copy and paste on Flutter, they may break. So you just need to understand the limitations that Flutter itself has on top of GLSL, and all of them just very, very straightforward.
Okay. Yeah, I appreciate you, like I said, taking the time to kind of walk us through this, and there's a nice handy looks. You keep pulling this up, the documentation. When you go to flutter.dev, you look at the docs, you go to the user interface, advanced UI, shaders. They have basically a super good introduction about what a shader is, how to get into it, and like you said, the link to that shaders website. So it should be pretty straightforward to pick up and learn. Cool.
Absolutely.
Is there anything else you want to say about shaders before we start the wrap up? Because we had quite a long episode, but definitely I appreciate all the knowledge you've been sharing.
I just want letting y'all know that this will be the playground. I'm gonna make it open source. It's closed source for some days now, but the thing that I tweeted, the light shader, it's open source. It's under my GitHub, Renan Araújo / glow stuff with shader, and also the motion blur. This I'm gonna just publish as a package pretty soon. Just finishing some tests. This will be called motion _blur _ scroll. And just to serve as a guide if you wanna start with the shader stuff. Also, check before trying these things out. Check out the master channel.
So the master channel of Flutter.
Flutter channel master. Yeah,
I thought you were talking about some channel master channel of shaders on YouTube. That I had to think for a moment. What you're talking about?
No, the Flutter master channel. I'm sorry. Would be a cool name though.
Yeah,
the master channel.
The problem is that there's so many acronyms and things in my head from different clients and different projects. I have to remember what's going on for what. And it takes a moment. Also, talking to somebody from US or talking to somebody from UK, it's like, wait, you're talking about meters or you're talking about inches? Give me what takes me a minute to start to put everything together.
Absolutely.
Yeah. Awesome. Yeah, this is cool. I like it. I need to sit down and do this. And I've been wanting to get into video games and stuff. And I think shaders, no matter what, they're kind of universal to a certain extent. So it's something I need
Yes.
to get
When we
into.
introduce 3D.
Yeah.
Yeah.
Cool. Again,
Okay.
thanks for
Cool.
your time. I really appreciate it. Now you said we want to get into contact with you. We can probably hit you up on Twitter, right? And
Yes.
we can see some of your other shaders.
My
So,
Twitter handle is
mhm.
yes. I will. I will start. I will publish more shader stuff soon that I'm doing on some personal projects. But the gimmicks and demonstrations and everything can be found at my Twitter. There's also it's important to follow Wolfgang, my coworker, that's a creator of Umbra. He has been working and messing with shaders on Flutter for way longer than me. So yeah, Wolfgang. I don't remember exactly his Twitter handle. Wolfgang, yeah, Wolfgang, and
Yeah.
yeah, that's it.
Yeah, I've
And
seen
also my
him posting a
Twitter.
lot about shaders.
Yeah, he did something with just rendering a shader, a very famous shader on Shader Toy. Let's go for Shader Toy. And it's like a fantastic one that just renders the entire freaking ocean. So if I go for browse and popular, it's probably the first or the second most popular shader on Shader Toy. It's this one, the Shaderscape, Seascape. This thing is like huge. It's very demanding on the shader part. Actually, on my machine is running like frames, seconds per frame right now on shader type, but on Flutter it's like 60. It's ridiculous.
Wow.
And this runs on Flutter, this shader, now with the increased capabilities. Some months ago, not possible.
Wow. That's really cool. I wish people, if you don't listen to the podcast, you're not actually looking at it. You're missing out on some really cool looking shader stuff.
Yeah. Look, I don't even know how to start looking at the source code, but people can go wide, and it's not that huge for the effect that we are seeing, right?
Yeah, definitely. This is very interesting.
Just 200 lines.
Yeah, that's not that much, but
Yeah, ShaderToy is also a useful website to learn shaders.
yeah.
They have cool demonstrations here too.
Well, thanks for making my weekend busy with looking at shaders. So I was hoping to get things done, but I don't think it's going to happen now.
You're welcome.
Yeah. Cool. I think yeah. To make sure people can get a hold of you, do you mind to say out your Twitter handle?
uh, Hint not a number, or if you go for Renan.gg, it's my website, and there we can have my Twitter, LinkedIn, and whatever. Hint not a number.
But yeah, you might need to spell it out because the pronunciation is, if you're not Portuguese, the
All
pronunciation is a
right.
little bit off.
RE not a number.
Yeah,
By like the entire thing. RE not a number.
already not a number exactly. Hanan. Yes. Okay. And with that, I don't think we. I don't know. It'd be great that we can wrap this up because we've had a long episode, and I think you've definitely given us a lot of things we got to kind of soak in. So I appreciate all the time and all the knowledge you shared, and I'm happy that you kind of made the process easy for us who don't know anything about shaders to understand how to get into shaders and how we can use them in our Flutter app. And a good useful point is to kind of replicate that Material 3 design, right, with Android. That's really cool.
Yes. And the fun thing is running on macOS. So this is the beauty of Flutter. It's just running that effect that's supposed to be on OneDrive only, where we're just running on macOS because we are ROG people. But yeah, it's my pleasure too to share and to talk about cool stuff. If I don't polish myself, I can just lose a whole day talking about this kind of stuff because it's quite fun.
Yeah, it is fun. Just now trying to find a good practical use for it. I mean, there is some, but some things there's not. Like the ocean is really cool, but I don't know if I can sell it to a client. right now.
I mean,
But it is cool looking. You can at least sell them Flutter technology and say, look, this is what you can do with it. So
absolutely.
cool. I say so. React Native try to do that. Maybe you can or cannot. I don't know. Maybe not.
I don't know.
But
Don't even want to know.
okay, cool. And with that, again, thanks for coming on, and hopefully we can have you again in the future.
Thank you. And yeah, call me. I'll be here.